Welcome back students. We are learning circles and this chapter is important for all the board exams like ICSE, CBSE, IGCSE or state board. Let us continue with our topic. Previously I have explained how a straight line can intersect a circle and what are the possible ways, and what is a diameter, chord and a tangent. I have explained in detail. Now let's see some more properties. Okay. So property 1 I want to mention about is whenever a tangent, this is a tangent because this line AP is touching the circle at only one point called A, at A. So this is a tangent, isn't it? And the property says that angle OAP will be 90 degree. So this OA is nothing but radius, as I explained already in the previous class. OA is the radius here, and AP is a line which is a tangent. AP is a tangent. Okay. So tangent will be perpendicular to radius. This is the symbol for perpendicular. Okay. You can write like this. So tangent is always perpendicular to the radius. This is what you have to remember. Tangent to a circle touches the circle at only one point, and the angle between the tangent and the radius is a right angle. Right angle stands for 90 degree. Okay. So angle OAP is 90 degree here. This is what we have to remember. Now immediately we get this doubt, why it should be 90. We need proof. Yes. So let's say this is a theorem and we'll start proving it. Okay. For the proof, what I need is, I need to join this O and let us join this P also. Okay. Isn't it a straight line? Just excuse me if it's not looking very much straight. Okay. So let's say you have join OP. Now we know that this is a triangle. Just we know that it is a triangle. Imagine we don't know that it is 90 degree yet, and we have to prove that it is 90. So let us consider OAP is a triangle. Now if you consider carefully, see here, the OP is a longer distance compared to OA. If you can observe carefully this one. Let's see how or why we have to consider it as so. We should also understand that OP is touching circle at, say for instance, let me consider this point as R, at R. Okay, it is touching the circle at R. Now isn't it implies OR is also radius. Already we know OA is also radius. As I mentioned before, from the center to the circle, if you draw any line, that will be radius only. Correct? So if OR is radius, OA is radius, then OR is also radius. Correct? Isn't it OP is greater than OR lengthwise? Why? Because see, since OP is equals to OR plus RP, implies I can say OP is greater than OR. Correct? If it's greater than OR, I can say OP is greater than OA as well, because both are radius only. So implies OA is the shortest distance on AP. This is my line AP and OA is my shortest. See, observe carefully. Imagine you have kept some ruler or something like that, and you're trying to turn it like a wheel. Okay, so from O to P, it's a longer distance. O to R, O to A, O to some other, say point E, it will be the same distance, isn't it? but not with the case of OP. OP, if you try to bring somewhere here, you will find OP, correct? It will be extended till here. Isn't it very clear that OP is greater than OA? And that OA is the shortest distance onto this AP. Whenever you have two parallel lines, this is my shortest distance between parallel lines, and this particular line forms the perpendicular to this line here. Yes or no? You have a line and this is my shortest distance from a point, then that becomes 90 degree here. That's because it's the shortest distance. Okay, so we conclude that OA is the shortest distance on AP. Therefore, we say that angle OAP is 90 degree. So whenever there is a shortest distance onto a line from a point, then that makes an angle 90 degree with the line. Okay, so that's the reason we say OAP here is 90 degree. Thus concluding the fact that tangent is perpendicular to radius. Okay, so that's how the proof goes on. Thank you.